Buddy, welcome to another video with McForce. Today I'll be showing you how I created an integration from Salesforce into a AWS gateway, and then from the gateway back into Salesforce. So the use case is, let's say we've got a student that wants to enroll to a university. So he is on a website, he fills in his application details, he clicks submit, and then that should go into an external system through the AWS gateway, and then in the external system updates are made, and then that should feed back into Salesforce. Alright, so I'll start then with the demo. And show you how basically I built this. So here I've got a Lightning Web Component. Obviously in real life this would be displayed on a website. So here I've got a Matthew Smith, and this is basically the enrollment form. So first of all, once I click submit, my LWC will create a contact. So if I go into my contacts and I create, I refresh, let's just, here we go, we've got a Matthew Smith. So then what I'm going to do is I'm going to basically explain you like exactly which components I used to have achieved this. So first of all, my LWC will create my contact, and once the contact is created, so basically on save, the LWC calls a contact controller Apex class, and this passing the new contact ID and JSON payload of what was just saved. This method does two things. First of all, it carries the contact to get the email field, and then it constructs a student registered platform event and publishes it using the event bus.publish. The method generates a UUID correlation ID at this point, and this ID will follow the whole transaction through every system. It goes into a platform event, into the Lambda, and into a DynamoDB. I'll show you about those a bit later. Right, so I just mentioned about the platform event. This platform event is not a record, it is a message. Once published, it is delivered asynchronously to any subscriber. Now in our case, we've got a trigger, and the event carries 5 fields. We've got a correlation ID, we've got a contact ID, an email, payload JSON, which is the full form data serialized as JSON, and event timestamp. You're probably wondering why we're using platform events and not direct HTTP callout through Apex. And because Apex cannot make callouts in the same transaction as a DML operation, the contact, insert, and callout cannot happen in the same execution context. That's why we wanted to make use of platform events. As I just mentioned, there is a trigger that listens to when this platform event is created, and basically that will call a event handler class. Now this handler receives the list of platform events from the trigger. It is designed to handle bulk events, not just one at a time, so it will loop through the events for each one, and it enqueues an enrollment callout queueable job. The contact ID, correlation ID, and payload JSON are passed as constructor arguments. The handler's job is purely orchestration. It receives the event, enqueues the work, and it gets out. As I just mentioned, it calls a enrollment callout Queueable Apex class. This is where the actual HTTP callout to AWS happens. I probably should have mentioned before any single line of infrastructure was built, I started with the API contract. Let me quickly switch to our Swagger editor. This is our YAML. So this is basically an OpenAPI 3.0 YAML spec that defines everything about how this API behaves. It covers 2 endpoints: post to create an enrollment and a patch to update the status. Security is defined using OAuth 2 with scope permissions applied globally, so every endpoint is protected by default. So here you'll see basically we've got monitoring. You'll see the post, the get, and the patch where we will be editing. So back to our enrollment callout queueable class. In this method, it executes and builds the HTTP requests. It sets the endpoint to AWS Gateway URL. It sets the method to post. It adds the content type header, the idempotency key header using the correlation ID, and the X correlation ID header. Then it sends the request and reads the response code. Then switch over to AWS to our API Gateway. So basically, the HTTPS request from Salesforce arrives at our AWS API Gateway, which routes it to the create enrollment Lambda function. This Lambda does 3 things in sequence. First, it reads the idempotency key header and checks DynamoDB for an existing record with that key. You're probably wondering what idempotency means. So if one exists, it returns the cached response immediately. No duplicate processing. If not, it validates the request body, checking that first name, last name, and email are present. Then it generates an enrollment ID, writes the record to DynamoDB within a 24-hour TTL, and returns a 201 response, which is obviously successful. So that makes sure that no duplicates are created. So for example, if somebody wants to creates like 2 forms or submits 2 forms in a 24-hour period. So yeah, but what this then does, it would create our enrollment record in our DynamoDB. So if let me just go to one like the whole table, a new record with Matthew Smith. There we go. Matthew Smith just created. You would see the enrollment status is pending. And then what I'll do is I will update this to accepted and save. All right. Let's go over to my contact record. You'll see the enrollment status is pending, as well as my integration status. So if I go and refresh details, it has now updated it to accepted, and my integration status also success. Basically what happened here is that DynamoDB stream fired. This is an event that triggers automatically whenever a record in the table is modified. The stream detected that the enrollment status field changed, captured both the old value and the new value, and immediately invoked the enrollment status sync Lambda. Let me just quickly show you that. Enrollment status sync. So this is the Lambda. This is basically the external application that I built that sits between DynamoDB and Salesforce. It reads the contact ID from the DynamoDB record, which was stored there when the original registration came through, authenticates to Salesforce using a JWT Beriflow by pulling the credentials from the secrets manager, and then makes a patch call directly to Salesforce REST API to update the contact record. Obviously, I had to create an external app. That's the old or the new connected app. that is of type JWT Berryflow. Yeah, that's basically how I did this. Please let me know what you think. Thank you very much.